Hello everybody, this is Dr. Vahid Aryadoost. In a series of videos, I'm going to demonstrate how to do scientometric analysis. In the first video, which is the current one, I'm going to discuss how to create a database for your scientometric analysis. The entire series of videos are going to provide you with a kind of step-by-step guidelines, mainly about the basics and maybe intermediate kind of analyses that you can run on your computers. I'm going to use a software package called CiteSpace, which has been recently used in the field of scientometrics analysis. So according to Wikipedia, scientometrics is the field of study which concerns itself with measuring and analyzing scientific literature. Scientometrics is a subfield of bibliometrics. Major research issues include the measurement of the impact of research papers in academic journals, the understanding of scientific citations, and the use of such measurements in policy and management contexts. So, like I said, the first step to start your scientometric analysis is to create a database. There are different databases that you can use in order to create the data that you need. I'm going to use the Web of Science for this demonstration. So it's important to remember that you need to connect to the Web of Science through your library. So I think I need to answer a question right away, a question that some of the viewers of this video might have in mind. If the library is not linked to the Web of Science or other databases, is it still possible to do the scientometric analysis? You could, because a database which I will introduce later called Dimension or Dimensions, maybe it's a plural word, provides you with a chance to download the data that you need and run the analysis. But the two so-called standard databases that a lot of people use for the scientometric analysis are the Web of Science and Scopus. So let's get started with the Web of Science. I've already have a shortcut here, but I'm not going to use this because I would like to provide you with step-by-step guidelines. So the first thing I'm going to do is to go to NIE's library, the National Institute of Education's library. You could do the same thing really for your own library. So it's here. You need to go to the list of databases. So let me just go through everything step by step. NIE library, and I'm going to scroll down to find the list of databases. I'm going to click the list of databases, and it's going to give me the list. Okay, so I'm going to click W because I'm looking for the Web of Science, and here we are, Web of Science NTU subscription. Anyone who is working at NIE and NTU actually has access to the Web of Science. It's going to take a little bit of while to get to the Web of Science. Alright, so I'm there, and it's important to remember that even though your institute is subscribed to the Web of Science, you also need to create an account here. So I've already signed in. If you have not signed in, you will if you click on this, you won't see your own name there. What you will see is sign in and register and something else. If you have not registered, do click on register and please register yourself there, because you need to have a personalized account. Why do we need a personalized account? Because every time that you do some search and you create a data set for yourself, you can save that. You can save the data set, and anytime you need to take a look at the data set again, it will be available for a certain period of time. Okay, I think that should be it. Now I'm in the Web of Science. There are different databases. All databases, Web of Science, KCI Korean Journal databases, Russian, Science Citation, and SciELO Citation Index. Now, for this presentation, I'm okay with the Web of Science core collection, which includes these. Search the world's leading scholarly journals, etc. Okay, so I just leave it as is, as the default, and I can start, for example, cognitive validity or something else. Now, as you see, I have put quotation marks on both sides of cognitive validity. This is a prompt for the search algorithm to look for cognitive validity as a whole and not cognitive and validity anywhere in the text. So it's going to look for the cognitive validity as a phrase together. So you could type in anything else. Let's say reading, if you're interested in reading, for example, because it's only one word, so you don't want to put quotation marks around it because it doesn't make a lot of sense there. Then you have different options here. You could use topic, title, author, publication name, etc. Topic is perhaps the most comprehensive option for you because it searches title, abstracts, author keywords, and keywords plus. And here are some examples. Okay, so I keep it as topic. Now let's say I want reading to be accompanied by a word like listening. So any text or any article that has the word listening and reading in the title, abstract, and author keywords and keywords plus will be selected by the Web of Science. If you use OR, you will change the protocol for search, which means that the Web of Science will be looking for any paper or any publication that has either reading in the title, etc., or listening. So you can imagine that the database that you're creating will be much more extensive if you use OR rather than AND. So I'm going to choose AND because I'm interested to find out what kind of research is done on both reading and listening. Now you can also select a time span. It's 1900s to 2020, to just present day. Or if you're interested, last 5 years, year to date, last 4 weeks ago, etc. Custom year range, and you can just custom it. If you're interested to do to make your search more specific, you can actually you can make it more specific here, and that will be it. So you're just one click away from creating your data set. Search. You're going to click search. So I'm going to do that. Search. And the results are going to appear. As you see, results with a few dots here. We already have an indication of 4,893 records have been recognized, but it's still trying to retrieve these records because that's a huge number of records, and there we are. All the records are here. Results 4,893. Now this includes a lot of things, and here are all those papers. Now you can see that they have been arranged. You can sort them by or arrange them by dates. That's from the latest to the earliest. You can reverse this by clicking on it. You can sort everything by the times they have been cited, so you can get a chance to see what is the most highly cited paper in this field. or usage counts, etc. You have also other options if you're interested. From what I see, the page is still loading, so I cannot get to see the drop-down menu here. I'll get back here, don't worry about it. I'll get back here when the loading is over. Like I said, this is a large data set, so I'm not surprised that it's taking a lot of time. Now I'm scrolling down, and as you see on this margin, this toolbar is very helpful. So if you're interested to limit, for example, the publication years to a specific range, you can just limit them. You can click, for example, 2020, 2019, 2018, this and this, and click refine. Then the 4,008 or 900 papers are going to be refined, and you're going to get just about maybe 2,000 papers. If you add these up, I'm not sure how many papers they will add up to. About this is about 1,200, 1,500, maybe something about 1,600 to 1,700 papers. You can click refine. I'm not going to do that at the moment because I think what I'm more interested in is to look at the Web of Science categories. I'm more interested in language linguistics, these two subfields. And I think I'm going to get around 1,000 plus papers. So refine. It's going to take some time. As you can see, the papers are being loaded slowly. Oh, 300 this time around. Okay, 300 because I had also checked these years. So it's giving me only the papers published in these years. I should have unchecked them, but anyway, never mind. So it's giving me these years plus these two only. So it's about 300 because these two databases, I assume they have some overlaps. These two categories have some overlap. So altogether, I have some 307 papers. Are you interested to refine it more? You can go further down. Document type. I'm just interested in articles. And organization. No, I'm not going to refine that further. So I just want to look into articles rather than, for example, notes, errata, and those kind of things that are not very helpful for my analysis. So I'm waiting for this refinement to finish, and then I'll get back to the data. So as I'm waiting, I can also show you some other options which are available, like funding agencies. Actually, you can see them, but my computer is a bit slow today. Authors, and the reason it's slow is that I have opened a lot of windows. Well, yes, we can see funding agency, National Institute of Health, NIH in the USA, and so on and so forth. Okay, so that's one thing. Now, we need to export the data that we have collected from this option, export option. The other thing you could do is to analyze your data, analyze the results. I'm going to do that later. The first thing I need is to export my data. I'm going to click on export, and you see a bunch of options here. Okay, because we're going to use this for scientometric analysis using CiteSpace. I need to click on other file formats and records from 1 to so my records are small, are 307. Now if you have more than 500 records, every time that you try to export the records, you can only do 500 of them. So it's going to be 1 to 500, then click the rest of the options, and then click export. And then you have to come back again, click on export at the button right behind this window, and start from 501 to, for example, 1000. That gives you 500 records. So as you can see, it reads no more than 500 records at a time. I think this is a limitation of the Web of Science, and I hope that this limitation will not be around anymore, maybe in the future versions of the Web of Science. Now, what do we need for record content? I'm going to click on this drop-down menu. It's very important for the scientometric analysis. The type that I'm going to use is called co-citation analysis. So cited references are fundamental. If you don't get cited references, you can't do that analysis, which is co-citation analysis basically. So I'm going to click full record and cited references. That's the first important criterion to remember. Now, file format, another drop-down menu, and it has to be plain text. Again, this is because we're going to use CiteSpace. So I'm going to click plain text, and we are ready to export. Okay, before I export it, I need to tell you that I've already created this folder here. I have named it CiteSpace on my desktop, and this is what is inside the folder. Inside the folder I have two subfolders. One is actually currently they're empty. One is called data, one is called project. It's much easier to name it in this way, because later you will see that CiteSpace will ask you, or will require you to create two folders. One where you park your data, like this, and one for importing the project results. So what I'm going to do is to export the data from the Web of Science into this data file. And that's really easy, very standard Windows operation that you often do when you save something. So it's asking me if the process does not start automatically, which it just started. It was asking if it's not gonna start automatically, you have to click the option that was provided. Now I can actually save it, or I can change the name here, because anyway you have to do this to download, underline something, for example 307. So it's important to note that the file that you're gonna use for CiteSpace analysis should have this format: download, underline, and something. For example, anything really, 307A, 307, 307B, or anything really. But the format has to be like this. And from what I have seen, the word download should have a lowercase d. That's another thing that I have seen. Okay, so I think we are ready. I'm going to click save. And that's the window I was talking about, so I can close it. Okay, I'm going back to my folder just to show you that, okay, I've got my download data. It's going to take a while for this to load everything. As you see, it's like a kind of amorphous data set which we can't really make sense of, but this is our treasure trove. We're going to mine this to find what kind of patterns emerge from this. And that's the beauty of Scientometrics. It makes things that are otherwise amorphous very meaningful and sensible. Okay, one more thing before I end the first section of this series is analyze results and create citation reports. This is the Web of Science. It's nice to get a feel for the data that you have already downloaded. It's like the kind of descriptive statistics that we often see in all sort of journals, journal papers. So it provides you with a sense of descriptive statistics. For example, how many papers have been published over the years, and how many authors have contributed to this data set, etc. So this is going to take some time. I'm going to pause this video here for a while and get back to you as soon as I get the results. Okay, so I've gotten the results here. This is what you will see. So I'm going to close this. All right. The first analysis, or the first type of analysis that the Web of Science provides us with, is categories. Then you can change publication years. You can change it to publication years, document types, etc. Now, for the number of results, you can basically click on this and get 25. That's the highest that you can get. And this tree map changes according to the number of the results that you have asked the Web of Science to provide you with. But you can actually choose other formats as well. Bar graph is also another way of visualizing the results. So I clicked on that button, and I think it's going to take some time. Yeah, so you can actually hover your mouse over these categories and find out how many papers are published per category. For example, in psychology development, we have 3 records, and the highest record belongs to linguistics. Then education research, that's another category, education and educational research. And if you want to figure out what records these are, you can click on View Records. And linguistic and language and linguistics, you can also click on this. We have got 96 records for that. I'm going to reverse to tree map. This is really another nice way of visualizing everything. So the size of every rectangle indicates the size of the publications in that category. If you notice, they don't add up to 307, they add up to a lot more, and the reason is that quite a few papers have been categorized under different themes or categories. For example, like I said before, linguistics has 248 papers, etc. Now you can also arrange them based on the publication year. You just click on publication years and you'll get this. It's only 5 years, so you'll get to see only 5 bar charts. You have 5 bars for it. You can also click on the tree map to get the tree map representation. 2020 is still ongoing. That's why it's perhaps the smallest among everything, or all other years. Document type in the same way, and you have articles, reviews, corrections. Actually, you could go back to the Web of Science and just get articles out. You don't want to get, for example, reviews or early access, etc. You can just, or book reviews. I don't recommend book reviews really for any analysis, right? So this is one way of creating a data set for your for your psychometric analysis. Now I'm going to use this is CiteSpace, and this is another database which I have already analyzed. It can provide you with powerful and beautiful visualizations like this. And the interface of the Web of the CiteSpace looks like this. This is CiteSpace version 5.6.R4, 64-bit. Yeah, I'll get back to this and the analysis on the CiteSpace in the following video. Thank you very much for your attention. If you liked the video, please give it a like, and please subscribe to the channel, and have a good day.